Hi everyone, I am Diveshwari. I am from CSCB. Now let's see about ARM processor. The ARM microcontroller stands for Advanced RISC Machine. It is one of the extensive and most licensed processor cores in the world. The first ARM processor was developed in the year 1978 by Cambridge University, and the first ARM RISC processor was produced by Acron Group of Computers in the year 1985. These processes are specifically used in portable devices like digital cameras, mobile phones, home networking modules, and wireless communication technologies and other embedded systems due to the benefits such as low power consumption, reasonable performance, etc. This article gives an overview of ARM architecture with each module's principle of working. ARM Limited offers designs for both 32-bit and 64-bit RISC multi-core processors. The processors use a much simpler instruction set than their Intel counterparts, which are based on the complex instruction set computing architecture. The two types of processors also employ different methods to optimize performance and increase efficiency. For example, Intel takes a hardware approach to maximizing performance, whereas ARM takes a software approach. The ARM architecture: arithmetic logic unit, booth multiplier, barrel shifter, control unit, register file. Priority encoder: the encoder is used in the multiple load and store instruction to point which register within the register file to be loaded or kept. Multiplexers: several multiplexers are accustomed to the management operation of the processor buses. Because of the restricted project time, we tend to implement these components in a very behavioral model. Each component is described with an entity. Every entity has its own architecture, which can be optimized for certain necessities depending on its application. This creates the design easier to construct and maintain. Arithmetic logical unit: the ALU has two 32-bit inputs. The primary comes from the register file, whereas the other comes from the shifter. Status register flags modified by the ALU outputs. The V bit of output goes to the V flag as well as the count goes to the C flag. Whereas the foremost significant bit really represents the H flag, the ALU output operation is done by a NORAD to get the Z flag. The ALU has a 4-bit function bus that permits up to 16 opcode to be implemented. Booth multiplier factor: the multiplier factor has three 32-bit inputs and inputs written from the register file. The multiplier output is barely 32 least significant bits of the merchandise. The entity representation of multiplier factor is can be represented by using a diagram. Control unit: for any microprocessor, control unit is the heart of the whole process and it is responsible for the system operation. So the control unit design is the most important part within the whole design. The control unit is sometimes a pure combinational circuit design. Here the control unit is implemented by easy state machine. The processor timing is additionally included within the control unit. Signals from the control unit are connected to each component within the processor to supervise its operation. An ARM processor is one of a family of central processing units based on the reduced instruction set computer architecture for computer processors. ARM Limited, the company behind the ARM processor, designs the core CPU components and licenses the intellectual property to partner organizations, which then build ARM-based chips according to their own requirement. ARM Limited does not manufacture or sell ARM chips directly. I hope you understand about the ARM processor. Thank you.